3 months ago, I was doom scrolling my own comment section at 2 a.m., which is a terrible habit, when I noticed something weird. A video I thought would flop had this incredibly engaged comment thread, people arguing, sharing their own experiences, coming back days later to continue conversations. Meanwhile, my quote-unquote banger video had comments that were basically just emoji spam and generic praise. That discrepancy broke my brain. So I did what any reasonable person would do. I spent the next 11 weeks building a system to scrape, analyze, and cluster 2.7 million YouTube comments to figure out what the hell is actually happening in comment sections. What I found completely changed how I think about content creation, and I'm going to show you exactly how to build this yourself. Let me walk you through the architecture first, because understanding the system matters for understanding the insights. We're talking 4 main components: a scraper that handles YouTube's API without getting rate limited into oblivion, a PostgreSQL database with some specific schema choices I'll explain, an NLP pipeline for sentiment and intent classification, and a clustering layer that groups comments into actionable categories. The whole thing runs on a single 8 gig VPS, which was a constraint that forced some interesting optimization choices. I'm using Python for the scraper and analysis layers, but the techniques transfer to whatever stack you prefer. Now the scraper. YouTube Data API v3 is simultaneously generous and infuriating. You get 10,000 quota units daily, which sounds like a lot until you realize that listing comments costs 1 unit per request, but each request only returns 100 comments max. A video with 50,000 comments burns through half your daily quota. So the first thing I built was a quota management system that tracks usage across multiple API keys, rotates automatically, and queues requests that would exceed limits. Here's where it gets tricky though. The API pagination isn't just page tokens, it's nested. Comment threads have top-level comments, then replies are a separate endpoint. If you're not careful, you'll miss all the reply data, which turns out to be where the most interesting engagement happens. I wrote a recursive fetcher that follows reply threads to arbitrary depth while respecting quota limits. The code isn't complex, but the edge cases are brutal. Deleted comments, private channels, comments with weird Unicode that break your parser. Expect to handle exceptions for about 30% of your scraping logic. The database schema took 3 iterations to get right. My first approach was simple: 1 table, each comment a row. Terrible idea. Querying by video, by channel, by time range, everything was slow. Version 2 used proper normalization, separate tables for channels, videos, comments, replies, with foreign keys. Better, but I was doing tons of joins for common queries. Final version uses a denormalized comments table with the fields I query most frequently duplicated, plus separate normalized tables for when I need relational integrity. Yeah, it's not textbook database design, but query times dropped by an order of magnitude. I also added a full-text search index using PostgreSQL's built-in vector, which lets me find comments containing specific phrases across millions of rows in milliseconds. The NLP pipeline is where this gets genuinely interesting. Off-the-shelf sentiment analysis, the stuff you get from TextBlob or Vader, is almost useless for YouTube comments. Why? Because YouTube comments have their own linguistic patterns. Sarcasm is rampant. Emoji usage completely changes meaning, and what looks negative might actually be positive engagement. Someone writing in all caps isn't necessarily angry. They might just be excited. So I fine-tuned a DistilBERT model on a manually labeled dataset of about 15,000 YouTube comments. The labeling took forever, roughly 40 hours of my life I won't get back, but the accuracy improvement was worth it. Off-the-shelf models gave me maybe 61% accuracy on my test set. The fine-tuned version hits 84%. The training itself used Hugging Face Transformers library, standard cross-entropy loss, Atom W optimizer. Nothing exotic in the training loop. The magic is entirely in having domain-specific training data. But sentiment alone doesn't tell you much. A comment can be positive and useless, negative and valuable. What I actually care about is intent. Why did someone bother typing this comment? So I built a second classification layer that categorizes comments into 7 intent types: questions seeking information, technical corrections, personal anecdotes, requests for future content, simple appreciation, disagreement with substance, and trolling/spam. Training this classifier required another round of manual labeling, though I used my sentiment model to pre-filter which comments were worth labeling. The intent classifier runs as a second pass after sentiment, and together they give me a two-dimensional view of every comment. The clustering system ties everything together. I embed each comment using sentence transformers, specifically the all, Minion, L6, V2 model because it's fast enough to process millions of comments without dedicated GPU infrastructure. Then I run HDBSCAN clustering on the embeddings within each intent category. What this gives me is automatic grouping of similar comments. If 50 people are asking variations of the same question, they cluster together. If there's a common misconception, it clusters. If a particular topic resonates, I can see exactly how many comments reference it. Now, for what I actually learned from 2.7 million comments. First, counterintuitive finding. Negative sentiment correlates with higher watch time on subsequent videos. Comments that express frustration or disagreement come from people who care enough to engage, and they come back. Second finding. Questions and comments are the single strongest predictor of a video becoming evergreen. Videos with question-heavy comment sections continue getting traffic for months because YouTube's algorithm seems to interpret question comments as signals of informational value. Third finding. The best performing videos have comment sections where creator replies spawn subthreads. Not just replies to top comments, but replies early in a video's life cycle that generate their own discussion. This creates what I call comment section depth, and it appears to boost recommendations. Fourth finding, and this one hurt, my intuition about what resonates was wrong maybe 60% of the time. Topics I thought were advanced and would attract expert viewers actually attracted beginners asking foundational questions. Topics I thought were beginner-friendly had comment sections full of experts adding nuance. The mismatch between intended audience and actual audience was dramatic. So how do you build your own version of this without spending 11 weeks? Here's the weekend project version. Use the YouTube API with a single key, accept that you'll hit quota limits, and just be patient. Store everything in SQLite. It handles a few 100,000 comments fine. Skip the custom sentiment model initially. Use a pre-trained one from Hugging Face. Accept lower accuracy. Skip the intent classifier too. Just do manual review of random samples. For clustering, you can use the free tier of a vector database like Pinecone or just run UMAP plus HDBSCAN locally. The insights you'll get from even a basic version are better than intuition alone. I want to be honest about what didn't work. My first clustering approach used k-means, which was completely wrong for this problem because comment clusters have wildly different sizes and k-means assumes roughly equal cluster sizes. I also tried using GPT-4 for classification initially, which technically worked but cost roughly $200 per 100,000 comments, completely impractical at scale. And my early schema designs prioritized write speed over read speed, which was backwards. You write once, but query thousands of times. What's next for this system? I'm building a real-time pipeline that processes comments as they come in rather than batch processing. The goal is to surface emerging patterns within hours of publishing rather than days. I'm also experimenting with using comment patterns to predict video performance before a video even goes live, basically training a model on historical comment-to-performance relationships and using it to evaluate video concepts. Early results are promising, but I need more data. If you want to start building this yourself, the core libraries are YouTube API Python for scraping, transformers, and sentence transformers from Hugging Face for the NLP layer, and HDBSCAN for clustering. All free, all well documented. The hardest part isn't the code, it's committing to the manual labeling work that makes your models actually useful. Your data is your moat. Everyone has access to the same algorithms and pre-trained models. The differentiation comes from having training data specific to your niche and your audience. That's what I learned from 2.7 million comments. The comments aren't just feedback. They're a data set waiting to teach you exactly what your audience needs.